Number 13. On a roller coaster ride, passengers travel in carriages around a track. On the ride, carriages complete multiple circuits of the track such that the maximum vertical height of a carriage above ground is 60 meters. A carriage starts a circuit at a vertical height of 2 meters above the ground. The ground is horizontal. The vertical height h meters of a carriage above ground, t seconds after the carriage starts the first circuit, is modeled by the equation h is equal to a minus b bracket t minus 20 squared, where a and b are positive constants. Part A, find a complete equation for the model. So using the information that we've been given, we can do a quick sketch of the graph that is modeled by this quadratic equation. According to the equation, the y-axis will be representing the height and the x-axis will be representing the time. And we are told the carriage starts a circuit at a vertical height of 2 meters above ground, which means that when it starts, t is equal to 0 and the height is 2. Because the equation is showing a quadratic graph with a negative coefficient, this means that the graph would be looking like that. And the other piece of information that we're given is that the maximum vertical height of the carriage above ground is 60 meters. So the maximum height can be put as 60 there. So if we put it in the format of an equation in the completed square form, we can write this as minus b brackets t minus 20 squared plus a. And we can use this to get the coordinates of the turning point of the graph, which will be 20 and a. So we can mark that onto the graph. And since we can see that the turning point is where the maximum height occurs, that means that the a is going to be equal to 60. So for part A, we can say that when t is equal to 0, h is equal to 2. So if we now substitute a as 60, h as 2, and t as 0, we can now use this to find b. H, which is 2, is equal to a, which is now 60, minus b, t is 0, minus 20 squared. If we minus the 60 on both sides, we will have minus 58 is equal to. We then have 0 take away 20 in the bracket, which is just minus 20, and minus 20 squared is 400. So we have minus b times 400, which is minus 400b. In order to find b, we would therefore do negative 58 divided by negative 400. The negative signs would cancel out, and if we work this out in the calculator, this would give us a value of b being equal to 0.145. A would be equal to 60 because that is the maximum height, and we've now found b as 0.145. So to write this model as a complete equation, we can write it as h is equal to 60 minus 0.145 bracket t minus 20 squared. Part B says, use the model to determine the height of the carriage above the ground when t is equal to 40. So for this, we would just substitute into the equation t as 40. So we would write it as h is equal to 60 minus 0.145 bracket 40 minus 20 squared. And we can use the calculator to work this out. And this would give us an answer of 2 meters. The question then says, in an alternative model, the vertical height hm of a carriage above ground, t seconds after the carriage starts the first circuit, is given by h is equal to 29 cos 90 plus alpha plus beta, and alpha is between 0 and 360, where alpha and beta are constants. Part C, find a complete equation for the alternative model. So for part C, we know that a cosine graph reaches its maximum height at 0 and 360, and the maximum height is 1. So the cosine of this angle 90 plus alpha is equal to 1, and the value of x that gives this maximum height is 0 and 360. So if we put 90 plus alpha is equal to 360, we can use this to find alpha. So if we map this onto the model that we're given, we know that according to the model, the roller coaster reached the maximum height 60 when t was equal to 20. Therefore, from this graph and equation, we know that at the maximum height, t is equal to 20. And using this, we can now substitute t as 20 to find alpha. And this would be 180 plus alpha is equal to 360, which means to get alpha, we would have to do 360 take away 180. Therefore, alpha is equal to 180. In order to find beta, we know that when t is equal to 0, h is equal to 2. So if we now substitute that into the equation, we can write this as 2 is equal to 29 cos 9 bracket 0 plus alpha plus beta, and this would be 2 is equal to 29 cosine 180 plus beta. We know that cosine 180 is negative 1, so this is 29 multiplied by negative 1 plus beta. So if 2 is equal to negative 29 plus beta, if we add 29 to both sides, we will get beta is equal to 31. Therefore, to write a complete equation, we can write it as h is equal to 29 cos 90 plus 180 plus 31. The next part of the question says, given that the carriage moves continuously for 2 minutes, part D, give a reason why the alternative model would be more appropriate. So the initial model that was given to us was a quadratic graph. And as we can see, this quadratic graph is just moving downwards. The alternative model was a cosine graph, and we know that the cosine graph is periodic, meaning it repeats itself. So for this question, we can say that the original model would keep going down and would only be valid from t is equal to 0 to t is equal to 40. However, the alternative model repeats itself and would be valid for multiple circuits of the roller coaster. And this agrees with what the question says, because the question said that on the ride, carriages complete multiple circuits of the track.